Okay, we are going to talk about Pythagorean Theorem today. Make sure your phones are put up. I can tell you I've graded enough of them so that I can see we do not have phone privileges.
Are you serious?
Okay? So there's at least one person that didn't make above a what? Above 50.
In this class?
In this class. I don't know. There's at least one. I haven't graded them all. I've gone through and I've graded some of my classes, but I haven't finished them all yet. In this chapter, if you have this calculator, or you have a calculator like this, you cannot use these this time. Because they have a function on them that you're actually tested on in this chapter. You're tested on your ability to simplify a radical. Both of these calculators will actually do that work for you. So you can't use them because it does the work. So you have to use something like the ones that are here in my classroom. And on top of it, all year long, I've said when you go to take the EOC, what type of calculator are you going to have to use anyway? One of those, not one of these. Okay? So, the first thing we're going to talk about is how to simplify a radical. Because most likely, when you did Pythagorean Theorem before, all you did was give a decimal as an answer. We're going to leave our answer with a radical in it, but we're going to make sure that it's simplified. Like simplifying a fraction. We don't leave 2 over 4. We would simplify it to 1 over 2. If there is something inside of the radical that we could actually take the square root of, then we go ahead and do that. So it would be important that you know at least through 12 of your perfect squares. Everybody should know what the square root of 4 is. 2. Square root of 9 is 3. And if you don't know it this way, 2 squared is 4, so the square root of 4 is 2. You should know at least through 12 because it makes this process easier. If I'm dealing with an even number, there's no sense in me looking at any of the odd ones that are here. And certainly if I'm at 20, there's no sense in me looking at a number that's more than half that big. So I'm going to look at things that are less than half of 20 to see if it goes into it. Well, there's only 2 perfect squares, 9 and 4. Does 4 go into 20 evenly? Yes. This would actually look like this. The square root of 4 times the square root of 5 does equal the square root of 20. But what is the square root of 4? So we could write this as 2 square roots of 5. And that would be its simplest form. And again, to me, this is similar to simplifying a fraction. We should be able to simplify a radical. So let's take a look at a couple examples. Square root of 12. In our perfect squares, what will go into 12? What goes into 12? 4. How many times does it go into it? 3. So I can see the square root of 4 times the square root of 3 would have given me the square root of 12. But that is 2 square roots of 3.
Can we not just write it 4 square roots?
You can't write it this way because this can be simplified. What is the square root of 4?
No, I mean, like, what you're doing is like the first step.
Okay, the first step, all I did was factor this out. Right? Why did I use 4 and 3? Why did I not use 6 and 2? Because 6 and 2 are not what?
Perfect squares.
Not perfect squares. I want to take out something that I can take a square root of.
6 and 2.
If I do 6 and 2, okay,
Then you gotta put out
then I've got to do this again. 3 and 2. And then if I see 2 of them show up, it can come to the outside, and the 3 would stay on the inside. Which is why I say do it this way. It's easier.
now this one is gonna be
What will go into 90? Let's look at our list. If I'm looking at the square root of 90, I want to look at the perfect squares. And 9 will go into it, right? It'll go into it 10 times. But what is the square root of 9? So this would be 3 square roots of 10.
I learned this like 9.
Everybody okay so far?
Where are you getting like your final answer from?
Because this is really being multiplied. This is implied that it's what? What is the square root of 9, Jesse? Square root of 9 is what?
3.
Can I take the square root of 10? No, so I just bring it down. What was the square root of 4? 2. Can I take the square root of 3? No, I just bring it down. That help? Square root of 52. Think about our list. 4, 9. The next one in the list would be 16. Next one in the list would be 25. Next one in the list would be 36. Once I'm past half, I don't need to look at the list anymore. 36 won't go into 52, will it? 25 won't go into 52, will it? But I could check to see if 16 will go into it. Just take 52 and divide it by 16. It comes up to a decimal. So 16 won't work. I don't even need to try 9 because it's an odd number. But how about 4?
It goes in your 13.
Goes into it 13 times. But what is the square root of 4? So this is 2 square roots of 13. Again, at the halfway mark, I should look. Well, the halfway mark of 72 happens to be 36. 36 goes into 72 twice. Okay, let's talk about 9 and 8. I could. Don't make this harder than it is.
Either way, right?
This is going to have more work to it. Here's why. What is the square root of 9? Is there anything that it can go into 8 that I can take the square root of? So, again, if I think about this, this is 3 times the square root of 4 times the square root of 2. But what is the square root of 4? So I now have 3 times 2 times the square root of 2, which is 6 square roots of 2. This is also what? 6 square roots of 2. Think of it this way. If I had 8 over 16, what do you know that that's going to simplify to? 1 over 2. And you got that by dividing it by 8. But what if I'd have divided it by 2? That would have been what? That would have been 4 over 8, right? But there was another step then to do, wasn't there? I had to divide them both by what? I could have done 2 again, which would have given me 2 over 4. But what would I had to do then? I'd have had to do it again. This is the same concept. The bigger radical that I can take out, that is, I can take a perfect square of, the less steps I'm going to have to do. Which is why I say you should look at the halfway point and work backwards through the list versus working from the small ones and working up. Buddy, all right? Okay. Now, what we're going to do today is work with the Pythagorean Theorem and its converse. The Pythagorean Theorem should not be new to any of us. Pythagorean Theorem says a squared plus b squared equals c squared. And the only side that's critical then is the c side. And the c side is always across from the 90-degree angle. This side you should always identify first. The hypotenuse. A and B don't really matter their order because a squared plus b squared would be the same as b squared plus a squared. I'm just adding 2 numbers together. The Pythagorean theorem says if this is a right triangle, this formula is true. The converse says if this is true, then it will be a right triangle. So, not anything that's new here. You've seen it before. The part that we're going to do that's different is we're not going to put our answers in decimal form. We're going to simplify the radical. So, in example 5, what do I want to identify first? I want to identify what the C side of the triangle is. 7D or 14? 14 is the C side. The other 2 don't matter.
What do you mean they don't matter?
7 squared plus D squared wouldn't matter if I wrote D squared plus 7 squared. Should be equal to 14 squared. 7 squared, 49. 14 squared, 196. What am I going to do to get D by itself? Subtract the 49. I get 147. And the opposite of squaring something would be what? Yeah, the square root. In the past, what you've done is you've converted this to a decimal. What we're going to do today is we're going to simplify this radical. If we can simplify it, we're going to simplify it. In my perfect squares, 49 goes into 147 3 times. But what is the square root of 49? So this would be 7 square roots of 3. So the only thing that's new today for you is your ability to simplify a radical. That's the only thing that's new. Everything else you've done before. Okay. What side am I going to want to identify first in the next example? The G side is the hypotenuse. 3 squared plus 5 squared then will be equal to g squared. 3 squared is 9. 5 squared is 25. 25 and 9 is 34. And I take the square root of it. If I was looking at my perfect square list, is there a number that'll go into 34 that I can take the square root of? No. So this simply is my answer. G equals the square root of 34. It's divisible by 2 and 17, neither of which I can take the square root of. Everybody okay so far? Okay. Pythagorean triples are 3 whole numbers, in other words, no decimals, no fractions, that satisfy the Pythagorean theorem. A squared plus b squared equals c squared. The 2 most common ones are this: 3, 4, 5, and 5, 12, 13. These are the 2 most common ones. These are common because they're used in construction all the time. In fact, a roof pitch in the south is very likely to be a 5, 12, 13 pitch. Up north, it's very likely to be a 3, 4, 5. Why would there be a difference between the pitch of a roof, the steepness of a roof, in the south compared to up north? Snow. If the roof isn't steeper up north, the snow will accumulate on the roof and the roof will cave in. The reason for learning about triples is once you learn about them, you begin to recognize them in other problems. There are more in this same group. You can find the rest of the family. There's actually a family of them by simply multiplying each one in the group by 2. 6, 8, 10. I can go back to the original one and multiply it by 3. 9, 12, 15. And the reason for learning about the family of them is it's real likely that you'll see them on your standardized tests, and once you know them, you don't actually have to use the time to solve the Pythagorean theorem. It's going to save you some time. The next one in this family, by the way, this would go on and on and on forever. The next one in this family would be 10, 24, 26. The next one would be 15, 36, 39. And again, this would go on and on and on forever. And you just simply find them by multiplying by 2, then by 3, then by 4. So to be a triple, it has to be what type of numbers? Whole numbers. No fractions, no decimals. Everybody good? Okay. By the way, here they're asking me to determine if this is a right triangle or not. Could this be a triple? The answer is right there. No, because that's not a what? A whole number. But I am going to see if a squared plus b squared is equal to c squared. 4 square roots of 3 squared plus 4 squared equals 8 squared. Four square roots of 3 squared is 48. 4 squared is 16. 8 squared is 64. (48) plus 16 is 64. So since a squared plus b squared was equal to c squared, this is a right triangle.
It's not, how did you do that, the whole 4?
This?
Yeah.
Okay. First off, you could learn how to punch this into your calculator. But the other thing that you could do is you could do this. When you have a square on something that's being multiplied, it's the same as taking 4 squared times the square root of 3 squared. What is 4 squared? 16. When you square a square root, they're the opposites of each other. They cancel each other out. So it's just what? 3. And what is 16 times 3? 48. But you can punch this in on a calculator. But you'd have to make sure that it was inside of what? Parentheses in order to do it. We good?
Absolutely.
Could this be a triple?
No.
No, can't be a triple because they're not whole numbers. We are going to see if it satisfies a squared plus b squared equals c squared. 2 square roots of 3 squared plus 4 square roots of 2 squared, and we're going to see if it's equal to 3 square roots of 5 squared. Well, this would be the same as 2 squared times the square root of 3 squared plus 4 squared times the square root of 2 squared equals 3 squared times the square root of 5 squared. Two squared is? The square root of 3 squared is 3. 4 squared is? Square root of 2 squared is? 3 squared is 9. Square root of 5 squared is 5. 4 times 3? 12. 16 times 2? 32. 9 times 5? 45. Is 44 equal to 45? No. This is not a right triangle. And again, you can learn to just punch this into the calculator. It would give you 12 as an end result. Punch this into a calculator, it would give you 32. Okay? Questions? Next page. Am I good now?
Yeah. Oh, Mark
No? Okay. If a triangle is not right, in other words, when I plug things in, it doesn't come up this way, which would be right. If it's not right, it only can be one of two things. It can be acute or it can be obtuse. Okay? Here's what I want you to think about. Take a look at the two blue lines that I've just put in there. If there was a line that was magically connecting the end of these two, and I don't want to draw that in at the moment, let's say that this was currently a right angle. Okay? If I made that right angle so that it was obtuse, what happens to the C side of the triangle? It gets bigger. So if the C squared side gets larger, it's going to be obtuse. Here it's showing the C squared side is getting larger. So if the C squared side is bigger, it will be obtuse. Likewise, if I went back and I said, you know what? Maybe I'll make it so that the angle is acute. What happens to the C side of the triangle? It gets smaller. So here I can see the C squared side got smaller. So that would make it acute. If it's equal. If A squared plus B squared is equal to C squared, it will be what type of triangle? Right. If the C squared side is less, it's acute. If the C squared side is larger, it is obtuse. We good? So, first thing we're going to do here is determine whether this can actually be a triangle or not. Does anybody remember how to do that? I add 7 and 14, and if it's greater than 16, then it can form a triangle. The sum of two sides has to be larger than the third side. Yes, this can be a triangle. Then I'm going to check to see if it is right, acute, or obtuse. And I'm going to do 7 squared plus 14 squared. And I'm going to compare it to 16 squared. Understand that these aren't always in order. So the C side would always be the largest one of these. 7 squared is 49. 14 squared, 196. 16 squared, 256. 49 and 196 put together is 245. Which side is bigger, the A squared, B squared, or the C squared side? If the C squared side got bigger, it became obtuse. First thing we're going to check, can it be a triangle? 9 plus 40 greater than 41. Yes or no? Yes, it can be a triangle. Then I'm going to check. 9 squared plus 40 squared. And I'm going to compare it to 41 squared. 9 squared is 81. 40 squared, 1600. 41 squared, 1681. These two are equal. If they're equal, what type of triangle is it? It is a right triangle. Is this then a triple? Yes. It's a triple because all three of these are whole numbers and they satisfied a squared plus b squared equals c squared. Can 11 or 12 be a triple? No, because they're not whole numbers. First thing I'm going to check on 11 is to see if it can be a triangle. 6.2 plus 13.8. Is it greater than 20? In fact, it's actually equal to 20, not greater than. This cannot be a triangle. If it can't be a triangle, do I need to check to see if it's right acute or obtuse? No, I'm done. This can be a triangle. In fact, we've seen it before. 2 square roots of 3 plus 4 square roots of 2 is greater than 3 square roots of 5. Okay? So it can be a triangle. And we're going to check to see if it's right acute or obtuse. Again, remember that when you're doing this, you're basically squaring each individual piece. What is 2 squared? What is 2 squared? 4. And the square root of 3 squared is 3. And that's 12. What is 4 squared? And the square root of 2 squared is? And 16 times 2 is 32. What is 3 squared? And the square root of 5 squared is? So, 44, 45. Which side is bigger, the a squared, b squared, or the c squared? C squared side is bigger, so it's obtuse. If I had to literally add 2 square roots together?
Yeah, just like how you have it set up.
Okay, hold on just a minute and I'll show you, but I won't do it up here because it's not relevant. What's your assignment today? To do that worksheet. Yeah,